Hello, Professor. My name is Manoj Singh Rajawat. I'm the student of computer vision class, and here I'm showing my project one proposal part. So the abstract of this is real-world object detection and tracking have become an important field in the research of computer vision, and still like the most of the areas are not explored. If you can say, for example, like for the disabled people and for the impaired people, there are a lot of possibility to design some of the softwares which can help them do their things safely and very easily. So here the problem is we are dealing with when the people who are disabled or impaired trying to pass the road, but they are not able to detect like which current signal it is. So we will take this on the signal itself. So like on the signal, we will install some computer vision software. So they will detect the pedestrian crossing, like who is crossing the road. If it is detected like it's a impaired person or disabled person, then we'll make the decision on their passing. So the introduction here is we use computer vision and machine learning techniques to detect the disabled person, like if they are on wheelchair, walking with a stick, and impaired. And this can be challenging due to outside environment. Like sometimes we have to check if it is the night time, and there can be object cluttering at the time, and poor quality of the video and camera view, etc. But a lot of research has been done on the pedestrian detection. So the night time and all object cluttering will be is basically solved, so we can go ahead. And there is a lot of research also has been done on the human behavior detection using computer vision. So first we will detect the presence of the physical impaired person on the pedestrian, and we'll check if the time is needed to be extended or not. So like if someone who is impaired is crossing the pedestrian and the pedestrian crossing time is about to end, like it's to 1 second or 2 seconds. So then what we will do will we are using computer vision to detect the presence of the impaired or disabled person on the pedestrian if they are still there and not cross the path. So what we'll do, we will extend the pedestrian cross path by maybe, for example, 10 seconds or 20 seconds. So this will give them enough time to pass the road safely, and we will keep the lights red until they are passed. So this is the idea behind this. So what we are using the YOLO object detector in this, because YOLO is considered to be the best object detector I've seen. So we will be going using YOLO. We'll be discussing more about YOLO in the next few steps. And there have been two YOLO versions we were using. So one is the YOLO version 2 and the another one is the YOLO version 3, for basically just to compare the results, like with which YOLO version we are getting the best results. So we'll discuss the results at the end of this. So how the project will flow. So basically the idea behind this is like this is the road and these are the vehicles crossing the road. So this is the road light. So here is the pole where the pedestrian crossing light is being shown. So when the people are crossing the pedestrian, there is enough time given to them by this controller, like the 20 seconds or 18 seconds, so they can cross the path easily. But when someone who is impaired or like the handicap, he's passing the road, there is nothing today installed on the pole which can detect and give them extra time. So what we will do, we will just detect their presence with this computer vision camera. There is OpenCV installed on this, and they have other libraries, and we will be using YOLO to detect their presence, like the real-time object detector. This will be the real time, and YOLO has been considered the best for the real-time object detection because YOLO's accuracy is more than 90% in some of the cases, and it works in the night time too. So that is the best we considered here. And what we'll do, we will get the input from this camera, like who is passing, so we will detect each person as a single unit, and we will give this input to the machine learning, like the object detection algorithms, And if the person who is passing is accompanied by the another one who is like helping them, so what we'll do, we'll just counting them as single unit. So like they are helping the other handicapped person to get past. So in these cases, if they are detected and the time is not end, like they are still on the line, so what we will do, we will send the controller a message like, or a or something to extend the time, so then the time can easily be extended. So then we go ahead. So to basically go with the flow, we are using the CNN, and CNN is known as convolutional neural network and is the backbone of the machine learning. So how the CNN works? So at least one convolution layer needs to be present in the neural network to call it CNN. So how the CNN works? The CNN is bound by the, in the backend there are hidden layers which works to find out the class, like which class of image it is. So for example, if there is an image we feed in the CNN layer, so first there is an input layer which divides the image in the pixels. We will discuss in after. So this image is divided in the pixels, and then hidden layers. This layer is previously trained to detect like what kind of features this image is having. So like this image is having particular features like cat, dog, and etc. So we can easily show them like what kind of class we are feeding in. So this image goes through the input layer, then the hidden layer, and then it goes to the output layer. On the output layer, we tell the algorithm like what kind of image it is, like what kind of features we have detected in the image. So like this is the bird, so we will show like this is the bird. So that's, and the accuracy is not 100% always. This can be more than 50 most of the cases and less than 100. But if the model is trained well enough, like in the YOLO we will be using, so we were able to achieve the accuracy of around 92%. So this is the whole idea about CNN. And the Jan LeCun was from founder of the CNN network. He was said to be the godfather of the CNN. So how the convolutional layer works? So it is basically divided into four parts. The one part is the convolution operation. It is consisting of two parts, stride and ReLU layer. The second one is the pooling, third one is the flattening, and the fourth one is the full connection. So what is the convolution operation? The first one is the stride. So what the stride is? The stride is basically the uh, the process in what we do in the convolution operation. In the convolution operation we just divide an image in the vector. So it is very easy for hidden layers to process the data. So we just divide this image into the vectors, and then we feed it to the feature map. So it helps remove the unnecessary detail from the image. We can create feature maps to obtain our first convolution layer. Okay, so then we move to there are two parts in the convolution layer. One is the stride. So stride is the number of pixels by which the image is moving. Like you see that the stride is 3 by 3. So we are moving by 3 by 3. And then the pooling. So pooling is basically used to reduce the spatial size of the convoluted feature. By this, the computational power is decreased. For example, like the image is bigger enough, so and it has a lot of objects inside this, so this will take a lot of time. But if we apply the pooling, so it will reduce the computational power, but it is because it can help us, the algorithm, to reduce the computational power. The second one is the ReLU activation function. So the ReLU activation function is the mostly used in the world's most used activation function, the convolutional neural networks. So that is it. The pooling is divided basically in two parts: max pooling and average pooling. As you can see by the names, the max pooling gives the um, returns the value of the maximum number of the matrix, and the average pooling returns the value of the average number of the matrix. The flattening is basically converting the pooling feature map into 1D column vector, so it is very easy for the algorithm to process. And then we go to the full connection. The full connection is basically not, basically all the hidden layers are getting connected to each other and giving the output to the algorithm. So this is how the CNN works, and that is the backbone of the machine learning. Now we move ahead to the YOLO object detection. So how the YOLO object detection works. So we will see like how the YOLO is going on. So let's take a look. So YOLO is known as you look only once. So for example, like when we are feeding an image to the convolutional neural network, so the idea behind this, we just keep iterating the image until we are getting our data, like what class of image it is. So it is time consuming and the process consuming, like it can take a lot of power from the processor. So how the YOLO works? So what the YOLO does, it takes the image and breaks them into the pieces, and it's very easier because the this image is passed only one time through the convolutional neural network, and it doesn't go on the iterations. So that is why it's basically used for the object detection. And one of the best thing is it's real time, so you can feed this on the computer vision system and they will detect objects in the real time. So that's what is the best part about this. And it is known for its three specialties. One is the speed. It's good, it's fast because it works on the single image and single processing, so that's why it's fast. It does not keep iterating. The second one is the accuracy. uh, in spite of the it's a one-time processing, it gives higher accuracy results, and basically in the real time too. So that's why it's good, because it gives the results in real time and it's high accurate, so we can use in most of the object detection algorithms. And learning capabilities, it learns from itself, like when we are feeding the convolutional neural network. So once the image is passed, it can classify it into, and the next time image comes from the different category, it classifies itself into a different category. So that's something good about it. So how the YOLO work? So YOLO divides the image into blocks, the grid cells. If you can see the red grid cells over here. So what does it does? It is putting the image objects, and the residual block is known as dividing the image into the grid cells. The second one is the bounding box regression. So what is the bounding box regression? So we move ahead. So this is the image we pass through the YOLO. So what is this is the car. So when the YOLO detects this car, it creates the bounding box around this image, when which can basically be used by processors to check what kind of object it is, to like keep it real-time tracking or etc. So this is the real-time image tracking. So this bounding box is created around the car. And the third one is the intersection or union, when the two kind of images are, two boxes are around the image, the larger one will be taken the consideration, which will be having the complete object as the intersection. Okay, so let's move to the methodology. So YOLO was first introduced in 2015, and it's considered the real-time object detection algorithm. It's the fast and more highly accurate. And like since then there have been a lot of versions coming around of the YOLO. The best one is the YOLO 4, but we completed this project on the YOLO version 3. And YOLO version 3 was built of 53 convolution layer networks, which was basically created from the darknet 19 residual and hybrid. YOLO version 3 is faster and more accurate than anything around CNNs. And YOLO version 3 is designed in such a way that is used by the GPU in a better way. So what does it mean? It means like when we pass the image, like for the iterations, it keeps the GPU busy. So it is not, it can be highly accurate but not the speed. But if we in the real time we need the high, like the in real time we need the speed as well. So that's why YOLO is best. It utilizes the GPU in a better way. And the another part is the YOLO predictors, the bounding box using the dimension clusters. So which is very easy to like the track the object, what kind of object it is and where it is. So that's the another part, that's the another dimension the YOLO detects. So that's good part. And the network predicts location and dimension of each bounding box along with the object score in each bounding box using logistic regression. There should be one if the bounding box prior overlaps a ground truth object by more than one bounding box, like we have seen here. It is the intersection. So we just keep the object which is covered by the bigger size, so then we consider it. And the data set, so the data set was not publicly available for the pedestrian crossing, so we go ahead with the ImageNet, Google Images, and pedestrian database from the Ainera. And then we created the custom database, and we had to train it on the YOLO for around 4,653 image sets. It was, and when the YOLO was trained, we feed it some different images like the car, bicycle, pedestrian object featuring. Why? Because when we are training a data set, training an algorithm, we should train as high image classes as we can. Because for example, if we are having the different class and it is not labeled in the algorithm, so it can try to label it something else. But if we are getting the image of the bicycle and it is already classed in the YOLO algorithm, so it will say, oh, it's bicycle, so it will say, it will do not falsify the information, it will just class them as the bicycle. It will not try to find out with the another object because it already did. So that's why it's good idea to train as much as data as we have. And the data set was randomly split into 3 being trainings, validation, test images. It was observed that YOLO does not require validation or test images at the training phase, but uses the loss function based on the prediction box overlay with the ground truth. So the results was fantastic. We got the accuracy of 92%. And the fun part is the YOLO 2 and YOLO version 3 both were tested because we need to compare the results. And obviously version 3 was best because of the precision rate of 0.989, and then respectively YOLO 3's precision rate was 0.81, and on the second side the recall rate was 0.92 and the 0.86 respectively. So YOLO version 3 was best in all the cases, and we got the accuracy of more than 92%, but we got some false information as well. So I'm showing you in the image. So if I go to this image, we detected this wheelchair as well, but we detected something which is looking like the wheelchair as a wheelchair itself. So this we can got, but we can improve this by more training, because if you look closely, this is looking like the clutch. This is looking like exactly like the clutch. So even the human mind can tell this is a clutch, but it is not in the real actually. And this is car, and the back side of this you can see it's a small car, but it is not a car. So there can be some false information, and it can be reduced with the more training, more data sets we have, so that we can do in the future to make it good. So the conclusion is automatic detection of the disabled pedestrian is a challenging task, obviously. And in the version 3, we tried and tested detect such people on the pedestrian. It was good, and we detected almost all of the people. We detected some false information, false people, but it is good because all the real ones were detected. It was 100%, and our dataset from the Google and other image source has proved that real image we achieved the accuracy more than 90%. So the system successfully detects all the 5 mobility ads. 5 mobility ads, kind of like the stick and the wheelchair, the person with the helping with the others one, and 2 more categories like the mobility scooter and walking stick, walking frame. So these are the categories we divided, and this is the video uploaded. And here we go on the quiz. So which model is used to detect the pedestrian crossing? So obviously we use the CNN. Click on the CNN, convolutional neural network. Elevate can be one of them, but it is not used here. Elevate is another proposed solution for the pedestrian crossing, but we are not using it. And when will the time of the pedestrian crossing be extended? So basically vehicle is not crossing, that's wrong. People are crossing the pedestrian, maybe, but this one is the correct one. Someone is detected on the pedestrian who is impaired. So let's look at the answers. How cool, you're good. We got the CNN and someone is detected on the pedestrian who is impaired. So our answers are right. And this is the bibliography we are using, and this is the references. Let's open this one. So this was the paper I'm referring to. This is the research paper I'm referring to. We got the results from here. We got the tables from here, and this was the image that was showing like they detected the wheelchair, but it was not the wheelchair itself. This was a class. So this is the main reference paper, and these are the external link of the images we are using here for this. Like we have used the external images here, this kind of. So we are giving the reference. So thank you. This was the solution. Have a good one.